This Newton's gravity stuff, hopefully you're getting the hang of it. There's really two parts to it: working your calculator and understanding the physics. In this one, I'm going to focus on the physics. Part of Newton's law of gravity, part of the force equation, is this part that we've nicknamed lowercase g, or gravitational field strength. What it does is it communicates how powerful the gravity is due to a certain planet or moon of mass m when you're basically some distance r away. Usually for gravitational field strength, the distance is the radius of the planet, because we've talked about a person being on that planet, but I guess it could be a different distance. If we were doing a bunch of experiments 1,000,000 meters above the moon, maybe it would make sense to calculate the gravitational field strength 1,000,000 meters above the moon. But unless I tell you different, it's just a matter of plugging in the mass and the radius of the object and then seeing what this lowercase g spits out. For the moon, well, for anything, the 6.67 number, it's a constant. I'm going to put the units in this time so you can see how they cancel out. You can skip the units, that just adds a wrinkle you don't need to concern yourself with. The mass of the moon is that 735 number. And then we're going to divide all of that by the radius of the moon. Really, this turns into a calculator exercise. Figure out your scientific notation button. If you're having problems, you could check on YouTube to see if there's a video explaining your calculator. If you're really having problems and can't solve it, maybe send me a picture of your calculator and I'll see if I can figure out how to do it. But this is just what I would call a plug and a chug. The physics is over. We put our numbers in the right spots. Now it's just a matter of calculating it. When I crunch it out and round it off, I get roughly 1.6. Now, unit-wise, we had kilograms here and a kilogram squared here. So this kilogram cancels out just one of those. On the denominator, we have meters squared, and in this one, we have meters squared. So they completely cancel each other out. When we're all done our math, we're to get the 1.6 number, and unit-wise, we're left with newtons and one of the kilograms. What that means is if you had 1 kilogram on Mars, it would take a force of 1.6 newtons to lift it. If you had 5 kilograms, it would be 5 times 1.6. The equation F equals mg works. We would just use the 1.6 number, where on Earth we're going to use the 9.8 number.